Now, let's look at the properties of carbon. Yeah, before we look at the properties of carbon, let's first discover the electronic configuration of carbon. In other words, let's look at the electronic configuration of carbon, and then it will guide us on how the properties of carbon can be looked into. Let's look at the properties of carbon. Properties of carbon. Let's look at the electronic configuration of carbon. Let's look at the electronic configuration of carbon. The electronic configuration of carbon is twofold. The electronic configuration of carbon is twofold, and here this means when we look at the electronic configuration of carbon as twofold, we discover that carbon has got two shares of electrons. And because carbon has got two shares of electrons, this means carbon belongs in period 2 of the periodic table. Yeah, carbon from its electronic configuration, from its electronic configuration, carbon has two shells of electrons, and because it has two shells of electrons, it thus belongs to period 2. It thus belongs to period 2 of the periodic table. And when we look at this electronic configuration of carbon, we find carbon has got 4 electrons in its outermost shell. And because carbon has 4 electrons in its outermost shell, this means carbon belongs in group 4 of the periodic table. Yeah, we can note this down. Carbon belongs to group 4. Carbon belongs to group 4 of the periodic table. Carbon belongs to group 4 of the periodic table because it has 4 electrons, in its outermost shell. Yeah, this is something interesting because carbon has 4 electrons in its outermost shell. Then that means it belongs to group 4. And because carbon has got 2 shells of electrons, as we look at its electronic configuration, then this means carbon belongs in period 2 of the periodic table. Yeah, let's look at the chemical properties of carbon. Let's look at the chemical properties of carbon. And here let's begin with the effect of heat on carbon. When carbon is burned, combustion of carbon, and most especially in air. When carbon burns in air, how does it react with air? For instance, we are going to discover when carbon burns in excess amounts of air, that is, when carbon burns in excess amounts of oxygen gas, then carbon dioxide gas is produced. And when carbon burns in limited amounts of air, then carbon monoxide gas is produced. Let's note down these two important reactions. Let's note down these two important reactions. Let's look at one, effect of heat. Effect of heat on carbon. Effect of heat on carbon. In excess oxygen, carbon, we are saying it reacts with excess oxygen, producing carbon dioxide gas. In excess oxygen, carbon burns. Carbon burns, producing carbon dioxide gas. Let's look at the equation for this chemical reaction. 1 mole of carbon, when reacted with excess oxygen, gas, then we get 1 mole of carbon dioxide gas. And how about in limited amounts of oxygen gas? Carbon burns in limited oxygen. Carbon burns in limited oxygen to produce carbon monoxide gas. Carbon monoxide gas. Let's look at the equation for this reaction. Let's look at the equation of the reaction, how carbon reacts with limited amounts of oxygen to produce carbon monoxide gas. 1 mole of carbon in a solid state reacts with 1 mole of oxygen in little amounts, producing carbon monoxide gas. We need to balance this equation. In balancing this equation, we shall find we have 2 moles of carbon reacting with 1 mole of oxygen to produce 2 moles of carbon monoxide gas. Let's look at the reaction of carbon with iron 3 oxide. Let's look at the reaction of carbon with iron 3 oxide. We are going to discover this reaction as a redox reaction. We are going to discover this reaction as a redox reaction. Let's look at the reaction of carbon with with iron 3 oxide. How does carbon react with iron 3 oxide? How does carbon react with iron 3 oxide? When carbon reacts with iron 3 oxide, carbon dioxide gas is produced and iron metal is also liberated during this chemical reaction. Let's have a look at the chemical reaction. Let's have a look at the equation for this reaction. Let's note down this. Let's note down this. Iron 3 oxide, iron 3 oxide reacts with carbon, produce carbon dioxide gas, and iron metal. Let's look at the equation for this reaction. Iron 3 oxide, 1 mole of iron 3 oxide, 1 mole of iron 3 oxide reacting with carbon in a solid state produces iron metal in a solid state and carbon dioxide gas. Let's have this equation balanced. We shall have 2 moles of iron 3 oxide reacting with 3 moles of carbon to produce 4 moles of iron and to produce 3 moles of carbon dioxide. When we look at this chemical equation, iron 3 oxide is acting as an oxidizing agent. Iron 3 oxide is acting as an oxidizing agent. And carbon is acting as a reducing agent. So when we look at this chemical reaction, both oxidation and reduction are taking place at the same time. So this chemical reaction is a redox reaction. This is a redox reaction because both oxidation and reduction are taking place at the same time.